The topic today, protective factor, was actually suggested by Professor May, and the reason you might be interested in that is actually directly in continuation with what Danny Weinberger just said. You want to prevent mental illnesses from happening if you can, because of the size and burden of mental illness. This is European data that many of you are familiar with. The global experience, very similar. You have an impact, this is Europe, of more than 500,000 million euro a year just for psychiatric disorders alone, and if you have a group of disorders with that impact on society, ideally you would like to prevent them from happening. And if you translate that into a research program, that implies that you would like to go away from manifest illness, which is often too late for prevention, and go back to what you know is causally related to that illness, which, as you've already heard, and which I guess is obvious for any disorders, are genes, environment, and their interaction. And as you've just heard about genes and gene-environment interaction, I will focus on what I'm going to be talking about neural mechanisms of environmental risk factors, of which there are many. This is an example by Jim Van Os reviewing schizophrenia risk factors, and you can see how they play out over the lifespan. You've just heard a lot about obstetric complications. There's also a lot that are later in development, but not really that much, as you've also heard, into adulthood. And all of those are extremely well validated. You could say, to the degree that's possible, they are proven to be causal risk factors for this disorder, but the understanding of the biology of those environmental risk factors is complicated because they're just more complicated than genetic risk factors usually are. So I'm going to be focusing today on 3 risk factors that have that status of having a proven impact on schizophrenia and often other mental illness risk, of which we think that they might have something to do with specific social stressors, although that remains to be proven or to be justified to you. That is difficult to process for a brain that's already altered, for example, through a neurodevelopmental trajectory that's different because of genetic background, as you've also just seen. I'm going to start with urbanicity. So being born and being brought up in a city, that is a very old literature that goes back to this famous paper, Ferris and Dunham in Chicago. That's Chicago, Great Lake is up here, and they found more mentally ill people as they went inside the city, a finding that at that time was interpreted as social psychiatric finding. That was the time when Americans had cars and they moved out of the city into the suburb, and the idea was that the mentally ill were left behind. They were clustering because of these drift phenomena in the inner city. But that has actually turned out to not explain the data. We now know from myriad studies really that urban life in some way is causal for mental illness. The first European replication of Ferris and Dunham was actually this paper. This is Mannheim's, where my institute is. There where it's black, where all the mentally ill live. This is where my institute was put in deliberately, because the Central Institute of Mental Health was meant to be a model institute for social psychiatry and do community psychiatry. So this whole story of urbanicity actually has determined the locale of my current institute, and as you will see a little later, still does to some degree. So as you've just heard, most schizophrenia risk factors act early in life, and that's true certainly for urbanicity, which impacts schizophrenia if it hits you early, probably intrauterine, and definitely not later than the 2nd year of life. So in that time span, if you are born into a big city, your schizophrenia risk goes up triple, goes up by 300%, making this by far the biggest known risk factor for schizophrenia. If everyone were born in rural circumstances, it has been computed that there would be 40% less people with schizophrenia around. And that risk interacts with genetic risk. As you can see here, if you are born in a city, you have this big risk increase. If you are born in a city and you're a sibling of a patient with schizophrenia, the risk goes up quite a bit, it's a gene-environment interaction, and that suggests usually that the genes and the environment work through a similar mechanism. The question then being what that mechanism is, and psychiatrists being psychiatrists, many papers were written over this over the decades, most of which thought that it probably has something to do with social risk. The idea is that social interactions in cities are somehow more adversive. You know less people, your social network is smaller, and therefore less of your social interactions are positive or validating. But there had been little experimental evidence, so we did an experiment a few years ago to look at that using a stress task in which you are doing cognitive tasks and you're given the impression that you're doing very poorly and that the experimenters are disapproving of this. This is a variant of what's called the Trier social stress task. It is in fact a German specialty to stress subjects socially in the scanner, and we took that and put it into an imaging context, which allows us to look at brain areas that are differently active if you are socially stressed compared to a condition where you also do cognitive tasks but you aren't criticized for it. And unsurprisingly, there are lots of them. There's a big network that you can think of as the network for social stress. And that wasn't novel. Our question in this paper was more specific. We wanted to know of those brain areas that are differentially active when you're socially stressed, are there any that are related to the size of the city you are born in? And that's relevant to schizophrenia from the literature I've just described to you. And we're also interested in areas that are differentially active depending on the current size of the city you live in right now. And the reason we're interested in that is that epidemiological research has consistently shown that the size of your current urban environment is related to risk for depression and anxiety disorders, both of which go up by 30 to 40%, which is an immense risk increase if you consider how common these disorders are in the population. So the question is, of the stress-related areas, are there any that are related to your urban environment? And the answer is yes, relatively simply actually. There's one brain area whose activity is related during social stress specifically to the size of your current urban habitat, and that's amygdala, which doesn't react very much in a rural circumstance. It reacts a little bit when you live in a small town and reacts a lot when you live in a big city. And we replicated that in the original paper in a separate sample, and then now several examples both in Europe and in the US and also beginning in Asia that replicate that in other cities as well. That makes sense because we know that amygdala is something like a final common pathophysiological pathway for depression and anxiety disorders because amygdala triggers a fight or flight response, and a hyperreactive amygdala is routinely seen in these disorders. So what we find here in the laboratory maps what the epidemiologically working colleagues find in the urban environment. Now, what about urban birth? What about the schizophrenia risk? Well, that highlights this area of the cingulate cortex, again replicated by us and replicated by a bunch of people now. That bit of the cingulate cortex, which I will call perigenual because it sits anterior to the genu, the knee of the corpus callosum, doesn't really fit very neatly to Brodmann areas, is hyperactive in people who are born into a city. And that is an area that's impacted very early on in brain development, schizophrenia, and which regulates amygdala, forms a feedback circuit. So we see a circuit implicated in emotional regulation, actually by some evidence also in gene-environment interaction active in the urban born. Now the bad news for city dwellers for city born, I should say, don't stop at function. This is functional data. To our surprise, we also found that if you are born into a city, your brain's structure is impacted. It is impacted in dorsolateral prefrontal cortex, which is actually quite a bit smaller if you're born in a city, and it is impacting that same area of the cingulate cortex in men only. And as Danny has just told you, this is usually a sign of an intrauterine effect because males are so much more susceptible to things that hit you in utero. So that's a good signature of that. Now, what does that mean? In order to find that out, I would like to contrast it with the second biggest social environmental risk factor for schizophrenia, which we know that it's migration. Now, if you are not living in the country in which you were born, first-generation migrant, your risk for schizophrenia around the world, in lots and lots and lots of studies, is around 280% up. So it isn't quite like being born a city. But interestingly, if you're the child of a first-generation migrant, if your parents were first-generation migrant, the risk goes up a little bit and inches toward 300%, making this the second biggest known risk factor for the illness. And as the example of the second-generation migrants already show, this is about living in a country whose social structure is different from the one you were brought up in, or your family is still characterized by when you're a second-generation migrant. This isn't about the stress of migration. It isn't about pre-migratory effect, which is something that the second-generation migrants have never experienced, right? So we now do, and a lot of people do a lot of work with refugees. We had a big influx of refugees into Europe, and we're trying to respond to that scientifically. Refugees also have a lot of psychiatric issues that have to do with flight, with being traumatized before they had to flee. But what we're talking about today is not about this. This isn't about flight risk. This is about a social structural phenomenon that is also found in people who have never had to flee. Now, sociologists and theorists can now debate for a long time what similarities and differences between being born in a city and being a migrant are, and they have. But with neuroscience, we can do something, I think, more compelling. We can look into the brain of people and ask, okay, is the effect of migration similar to what I've shown you for urban birth, or is it very different? In both cases, we probably would assume that the underlying psychological mechanisms are also similar or different. So we did an experiment to do this. This is a variant of that social stress test that takes social distance and ethnic effects into account. And what we found is that the effect of migration in this sample is exactly the same. So you can really superimpose these pictures. This is exactly the same area of the cingulate cortex that is impacted, again, only during social stress in migrants. And again, as before, we also found the effect of amygdala, which is regulated by that cingulate bit, but also of ventral striatum. And that's interesting because just as you can think of a hyperreactive amygdala as the final pathophysiology of depression and anxiety, you can think of increased dopamine release into ventral striatum as a final pathophysiology for psychosis. And we know from a lot of studies that that is actually what's happening in, for example, the high-risk state. So that would suggest that in migrants, socially stressed, we should see increased dopamine release and maybe also increased dopamine synthesis in striatum. And that is a study that we couldn't do at the time. We didn't have a PET yet. So we collaborated with Romina Mizrahi from Toronto and with a group from the IOP in London to look at that and found that. So this is very different migrants. This is Asians in Toronto mainly, and this is Caribbean migrants mainly in London. But, and they have the same stress task I've just shown you. And what you find is that normals do release dopamine during social stress, well-known phenomenon, but migrants release almost 4 times as much. So it's a really big increase in dopamine release in migrants, suggesting that there might be something to this idea. The sample was relatively small, but to this idea that a dysregulated ventral striatum has more dopamine release, which might make you psychotic under circumstance of social stress. And again, just as the functional effects of migrations are very, very similar to the functional effects of urban birth, the structural effects are also the same, right? In the same area of the brain, again, for men only, you find this structural reduction. And I would like to take that occasion to tell you about one third risk factor I think is actually quite interesting and which impacts schizophrenia but also mental illness more broadly, and that is socioeconomic status. Many of you will probably have seen this paper from JAMA. I know that because it was the second most cited paper of that entire year, only after the gravitational waves, in which they assembled every American's tax returns, so this is basically everyone but the president in here, and related it to life expectancy, right? And what you can see is that if you're very poor, you have some non-linearity down here. This has to do with probably health behaviors in the poor and also with the way the American health system works. But once you pass that, you're getting into this incredibly linear relationship between household income and how long you live. And even if you are among the richest Americans, so you're talking going from like 1.9 million a year income to 2 million a year, you still gain a few weeks of life expectancy, right? In fact, the difference between the richest and the poorest here is much, much bigger than the difference that you would have if you could cure cancer, right? This is a very, very big effect, and it's nothing to do with health behaviors. It has to do with status, because in humans, status is measured as socioeconomic status. Half of it is income, the other half of it is education, pretty much. And we know that humans react just as all other social species react, with a big health benefit of being on the top of a social hierarchy. This is an incredibly evolutionarily preserved thing that you can find in honeybees and in zebrafish and most certainly in primates. So how does status processing work in the human brain? This is a study by Ahmad Hariri, is another one of Danny's postdocs, who at that time had moved to Duke and did a study where he asked students, okay, imagine this letter is the United States social system. Those are the ones on the very top, those are the ones on the very bottom. Where are you, right? You could sort of name a letter. And Americans being, optimistic people, the average was about letter 7 or 8. And then he took that self-reported social status and correlated it with brain structure. It's a method called voxel-based morphometry, and this is what came up, right? This exact same area of the perigenial cingulate cortex again. In the same year, we did a functional study in which we looked at the functional consequences of processing status, and again found a differential activity in that same area of the cingulate cortex, especially if you were about to fall down, if you're about to lose your social status, which suggested that the same perigenial cingulate cortex area I've shown you is reactive to and also processes status information. Now, in the migrants, we have an interesting situation in that we cannot only measure migrant status, migrants also often have a lot of status mobility from the time they were born to adulthood. For like a non-migrant population, those things don't seem to change very much often. For refugees, the ones that we are looking at, they've often had a big reduction in status from their home country to us. For economic migrants, very often they have a huge increase in status from the time they were born to now. And we can replicate that status effect that Ahmad Hariri found in perigenial cingulate cortex, but we can also see a significant interaction. We can see an effect of status mobility, which we think is an important environmental determinant of how this impacts brain maturation. Now, if you put this together, those few studies together, we think that there's actually a privileged role for that bit of the cingulate cortex that you see here in blue, areas of the subcortical brain that it regulates, such as striatum and amygdala, and I haven't shown much about this, but there's a large literature, evolutionary younger parts of prefrontal cortex that regulate the cingulate in turn in environmental risk. And I actually haven't shown you data, but there's plenty of data that also suggests that a bunch of genetic risk factors, both common and rare ones, also impact on that circuit, which I would propose to you as a circuit for environmental risk. And I've shown you only a few environmental risk factors, also many others. But if you put them together and you look at things, for example, like poverty or childhood abuse, and look at what they all have in common, you find that really that part of the cingulate cortex is one thing that they have in common. You have, for example, specific effect of sexual abuse on parts of the somatosensory cortex, but you also have perigenuine. So this does seem to be a convergence site. Now, given that, let me come to the primary topic of my talk is how can we use this laboratory information on how risk factors impact the brain to do prevention, and ideally to do primary prevention, which means intervening in the environment. And I'm going to focus on the urban environment. And the reason I'm doing that is that the urban environment really presents a pressing global health problem. It's just a few years ago that mankind as a whole crossed that threshold in which more people live in big cities than in the country. Of course, throughout the evolution of our brain, our species, the vast majority of people have lived in rural circumstances. This is now no longer true, and this is actually proceeding so rapidly, driven especially by China, where more than 20 million Chinese are urbanized every year, not always with their explicit consent, it might be added, that by 2050, more than 2/3 of humans will live in big cities. And if you think about what I told you about the risk increase that big cities entail, you would like to know what can you do, how can you change the urban environment to be more conducive to mental health. And to figure that out for a few years now, we've been running a study to try and highlight resilience and risk factors in the urban environment. And that uses a method called ecological momentary assessment. You've heard from Tom Insel from his startup, and he's given you some market overview. Lots and lots of people are doing this now, but of course there's a long academic tradition of using this methodology to find out something about the environment. It's usually done through smartphones, in which you can ask people how they're feeling right now, what's your stress level, what's your well-being, and we're doing this in an experiment in which we combine this with geolocation. So we also know where people are when they ask them how they feel, and we have a lot of information about what's going on around them. So for example, we can measure noise or light pollution and air pollution to some degree. We have maps of socioeconomic status in the region or satellite maps of green space and so on. So we have a lot of information on what's going on, and so we're starting to figure out where in the city, in the country, are people feeling how. And then, after we do this for a week, usually, we bring people into the laboratory and do this stress experiment that I've just shown you. And the advantage of that is that we don't just have to count people who are mentally ill or not, which is a very coarse measure. We can measure something in the brain that is, we think, quantitatively related to risk. It's a quantitative endophenotype. And in this case, we can ask, okay, which of these exposures really have to do with risk and resilience as measured in brain? And I'm going to give you 3 examples of resilience factors. The first one, the obvious one, I guess, to ask is the social one. If we know that social stress is important, if we think that social interactions are problematic in cities, shouldn't the social network be a resilience factor? And the answer to this is yes. That's not a study by us. It's a group from the West Coast in the US which showed, and many have replicated since, that the more friends you have, the bigger your social network is, the bigger this amygdala cingulate network becomes, right? And this is true for your real friends, even true for your Facebook friends, right? There's several studies that show if you measure your virtual social network, it also has an effect on the same circuitry. It's a little bit shallower, but the effect is still there. Now, can we see this in real life? So this is data from the study that I'm just showing you. So if you look here, a bit of a busy slide, I'm sorry, but if you look here, what's shown on the y-axis is well-being. 100 is you're feeling perfect. 0 is you're feeling absolutely horrible. Most people feel kind of okay in the 70 range when you ask them. Now what you see here, the green light are people who are socially interacting when you ask them. The red light are people who are alone. And unsurprisingly, people who are alone feel a little bit less well than people who are with others. That isn't surprising, right? What you see on the x-axis here is a psychiatric risk measure. In this case, it's childhood trauma questionnaire. It measures whether these people have been abused, traumatized, beaten as children. And we know that the more that is true for you, the more you're at psychiatric risk. Now, both the green and the red line are pointing downwards, which is also not surprising. It means that a psychiatric risk population, on average in everyday life, will feel worse than a population that isn't at risk for mental illness. Unsurprising again. What is surprising, or at least interesting, is that these two lines are in parallel. There's a significant interaction here. And what's happening is that the people who are most at risk and feel the worst are the ones that benefit the most if they can engage in social interaction. The social interaction benefits the risk population most. And that feature, which you can only measure really using ecological momentary assessment, which we call social gain, is a huge, very potent predictor of exactly the same brain circuit I've shown you linking amygdala to cingulate. So this is an important feature, resilience feature of the ambient environment that relates to social interaction. Second example, movement. We know that moving is good for us, right? Most of the studies that are being done in mental health looking at movement have been examining exercise activity, aerobic exercise on a bike or running or something like that. That is beneficial and it impacts the hippocampus, and you know, we do studies on this. But most of the everyday activity, of course, isn't aerobic. Most of the everyday activity is you walking around, taking some stairs, doing stuff like that, which again you can measure with very high precision in the ecological momentary assessment approach. We now know from a bunch of studies that have appeared in the last 2 years that non-exercise activity is really important for your mood, in the sense that if you move more, you feel better, and if you feel better, you move more. There's a virtuous circle that is different from exercise activity, which makes you feel better, but if you feel better, you don't do more exercise. So it isn't a virtuous circle, if you will. Now, if you look where in the brain, there is a mediator of the interaction between how well you feel and how much you move. This highlights strongly, actually, the subgenual cingulate cortex, right? This is part of that cingulate bit I've shown you, but it's very strongly subgenual. That's interesting because we know that a small subgenual cortex is a risk factor for depression. If this area is small, your risk for depression is higher, and your response to traditional therapies is worse. There have been studies showing that a small subgenual cortex predicts worse response to antidepressants, SSRIs, to cognitive behavior therapy, to ECT, and to deep brain stimulation. So basically everything that you can throw at depression or conventional armamentarium acts worse if you have a small subgenual cingulate cortex. Now this is where you can now gain some more insight using ecological momentary assessment. What you see here, again on the y-axis, well-being, how well do you feel, and on the x-axis you see how much you move. The more you move, the better you feel. Just shown you that. But this is now stratified by people who are at risk. They have a low volume of the subgenual cortex, and people who are not at risk with this biological marker. And what you see is that the at-risk people feel a lot worse if they don't move. Right? And this is probably part of why they're at risk, because we know that if you're getting into a depressive episode, you start to move less, you start to sit in the sofa doing nothing, and the low subgenual cingulate cortex group has a bigger hit when that happens. Interestingly though, they also have a bigger benefit if you do get them to move. Like if you manage to really get these people to move more, they have an even bigger benefit in movement than the non-risk population, which would strongly suggest to us that that should be part of a treatment regimen, especially for treatment-resistant people, and this is something that we're now currently proposing to study. Final example that I would like to give you is nature. On the most basic sense, the difference between the city and the country is that you have less nature access in cities. So there's been a long line of thinking about how nature access benefits well-being, and there's an overwhelming literature that shows that nature actually does positively impact well-being. But there had been very little done about how that works in the brain. This was a study we did with Greg Bradman, who was a graduate student at Stanford at the time that I jointly supervised. And this is simply an experiment in which you ask people to take a walk in the city or walk in the countryside in nature, and look at their brain activity before and after using a method called arterial spin labeling, which is very good to give you these absolute differences in a subtraction paradigm. Now the effect is very specifically, again, in perigenial cingulate cortex. People who went into the woods felt a lot better, well-being was higher, they were cognitively better. Much of that was due to the fact that they were ruminating less, right? So rumination, which is shown here, is basically blocked by nature access, and rumination, that effect of rumination blockade, which explained the benefits, was mediated by that part of the perigenial cingulate cortex. So highlighting the same area again. Now this is a controlled experiment. How does this work in the real urban environment? This is where our method of ecological momentary assessment comes back in, and perhaps unsurprisingly, although that actually hadn't been shown before, in the urban environment, the more green space you are being exposed to, which is shown here on the x-axis, the better you feel. Right? So this is not going into a park. This is really more seeing some trees from a distance. We can actually show in the paper that that effect is very largely visual and seen at a distance. And the more of that you have, the better you feel. Most of these lines are pointing upwards, both in a discovery and a replication sample. Now, one thing that only ecological assessment can give you is to appreciate that the sensitivity of individuals to nature is very different. Like some people react a lot to it, the slope of the line is very high, and some people only react a little to it, the slope of the line is very low. And you can now go and ask, okay, what's different between the people who strongly react to the urban resilience factor of green space and the ones who react very little? And when you do that, you find that the people who strongly benefit from green space are people who cannot regulate their amygdala through the prefrontal mechanism that we think is usually at play there. This is a standard paradigm in which we show aversive pictures and people have to use prefrontal cortex to regulate their amygdala back down again. And those people who can't do this are the ones that benefit from green space, which suggests that the urban resilience factor has an emotion regulatory function that's especially important for people who can't do this intrinsically. That would suggest that these people are a risk population. And so we went back into our database and found that that is actually true. Those are people who are more harm avoidant, so they're by personality they are at risk. They are socioeconomically deprived, and they actually have a lot of poverty and lower household income. So a risk population benefits from this resilience factor, just as I've shown it to you for social interaction. And one of the things you can also do using the geolocation aspect is to ask, where in the city do you find these people? I don't know if you still remember this picture, I showed it a while to you. This is the original 1965 paper looking at the incidence of mental illness in the city of Mannheim. This is a reconstruction, 2017, using big data, satellites, lots of other stuff to look at the risk and resilience landscape, which looks very, very, very similar, in fact. There's still, the hotspot is right there where it was in 65. Right? And now we can use our localization technology to ask, okay, those people who benefit most from trees. That risk population, where in the city do you find them? And the answer is you find them right there in the inner city where there are no trees, right, where the green resources are reduced. So the people who would benefit from it the most are the people who get it the least, right, which is also kind of similar to what you find with social interactions in outpatient groups. So I've given you 3 examples of resilience factors, but I would like to point out to you that there are more, right? So there's optimism, for example, as a personality feature. We recently reviewed these resilience factors, actually an idea by Professor Meyer to do so, and there is a prominent example for this perigenial cingulate cortex, amygdala, ventral striatum circuitry in resilience, but there are also some other line of evidence that would suggest that resilience is also more broader-based, fascinating, I think, neuroscience phenomenon that, as I've tried to show you, we can try and use to develop some interventions for it. And that will be my final point. This is urgent, and what we need really is an ecosystem perspective on trying to develop and deploy preventive interventions that are conducive to mental health. If you take the example of cities, we know that for energetic reasons alone, the cities of the future will be incredibly dense. They will not be like anything we know. They will be like Hong Kong, right? This is examples of Hong Kong, or they will have to be even denser, simply for energetic reasons. The climate change very largely drives urban and social changes that exacerbate these findings. People have to withdraw from coastlines. People have to live together energetically. Migration flows are increasing. So these phenomena that we've been describing today gain traction. And we've recently, with a bunch of people who are interested in this field, come together and try to develop a proposal on how to do an ecosystem perspective that includes mental well-being into, for example, climate change models, which is important because mental health, which is and in some parts of the population, the major burden for population isn't included in climate change models at all. And there's very good reason to believe that the effect of climate change on mental health through the mechanisms that I've described to you is going to be deleterious, and that we need to be very mindful to try and think how in a situation like this you can ensure access, for example, to nature, to green resources. It's not a trivial problem. We are researching a bunch of stuff such as vertical greening and some other things that you can do to try and do this. But we have to look at this also from an equality perspective. Access equality is going to be an important factor of mental wealth, very similar to how income equality or inequality is.